Okay, you guys, we have inverse trig functions. So think back to probably like algebra, geometry, definitely algebra 2, what inverse means. That means you're solving for the other variable. So if you have y equals 2x, that means you're solving for x. So you would get x equals y over 2, but then in the end, you flip your variables back. So it would be like y inverse equals, now I forget what I said, 2 over x or something. I forget what I said for sure. But anyways, so you're solving for the other variables essentially. So first we're going to start with derivatives. Differentiate with respect to x, sine of y would equals x. Keep in mind our goal is to have the x's in the derivative. So we're going to start with just our function, sine y equals x. By the way, this is kind of like the proof for it, and then I'm going to give you the rest, but you could work through all of them like this, and this is why it works. So if you take the derivative of sine y, you get cosine y dy. The derivative of x is just dx, 1 dx. So I'm going to put my dx's together, or my dx with my dy. So I have cosine y dy dx equals 1. So I just divided everything by dx. Now I want to get my cosine y on the other side. So I have dy dx. I have the derivative of something, the derivative of y with respect to x, because remember we want x's in our end thing. So dy dx equals 1 over cosine y. Okay, how can we get rid of that cosine y? So now you need to think back to all of that trig that we did in the beginning of the year that we complained about and hated. So what's it called? Trig identity, I guess. Yeah, from your identities, could help us to get rid of cosine y. So if you want to pause it and think about it and see if you can figure it out, what could we replace it with? Now would be the time. So I'm going to go on. So recall sine squared y plus cosine squared y equals 1, which is a part of the Pythagorean theorem. It's used in the Pythagorean theorem. So if we solve this for cosine y, we end up with 1 minus the radical of 1 minus sine squared y, which I'm going to replace in my derivative. So from down here, I'm going to replace cosine y with that. So that's going to give me dy dx equals 1 over 1 minus sine squared y. However, now we can look back in the beginning. What did we have in the beginning of our problem? Our original problem is sine y equals x. So what can we replace? Well, what can we replace sine squared y with? We can replace it with x squared. So now I have x's in my problem. I know I'm moving quickly, but you can go back and look at it. It's also in chapter 17 of the AP Princeton Review book, page 225, 226. So now if you think about it, so this is dy dx equals 1 over the square root of 1 minus x squared. What if I use, so going back to sine y equals x, what if I found the inverse of this? How do you get that? So how do I get how do I get y by itself? You take the inverse, that's what I meant to say. So not find the inverse. How do you get y by itself? Well, you have to take the inverse. That's the only way to cancel out that sign. So you take the sine inverse of both sides, and that would leave you with y equals sine inverse of x. This right here and this right here are the same thing. Okay, they mean the same thing, which is why dy dx equals d dx sine inverse x, which we just found out to be 1 over the radical of 1 minus x squared. So the derivative of sine inverse x equals 1 over the square root of 1 minus x squared. Okay, on the next page, yep, I'm going to show you all of them. This is a lot. You need to pause it because I'm going to move on. So you have sine inverse, tangent inverse. Keep in mind the u is just because if you were using u substitution. So this is what you get, your general formula. So you might have to do some manipulation if you have something other than just an x in place of u, but in general this is what you get. So I'm going to move on, pause it if you need to copy these down. These you need to have memorized. Notice some of them have boundaries because we can't go below or above u on our sine and cosine graphs, etc. Okay. Examples, so find d dx of sine inverse of x squared. So we know it's going to follow the format that we just had. 1 over the square root of 1 minus x squared. However, our x is x squared rather than just a plain x, so we might have to do some manipulation of it. So what you have to account for the chain rule. So what is the derivative of x squared? It's 2x. So we're going to get 2x over 1 minus x squared. Notice this is my u equals 2x. The derivative of u is 2x. You substitute that in. Quantity squared, which in turn just gives us this. So taking the derivatives of these is a lot of plugging and chugging. Okay, so it's just following through with what the formula is. You're plugging into the formula. So I took, this was my u, again, u equaled x squared. I didn't show this, but the derivative of that is 2x, which comes in right here, and then I replaced it down there. Okay, find d dx equals tangent inverse of 5x. So again, d dx of tangent inverse of 5x. So what is our general tangent formula? You should know that tangent is 1 over 1 plus u squared. So my u in this case is 5x. Okay, and the derivative of 5x is 5. So we have 5 over 1 plus 5x quantity squared, which is 5 over 1 plus 25x squared. So again, this 5 up here and this 2x come from taking the derivative of the variable. C, find d dx of secant square, or secant inverse x squared minus x. So this one's a little bit longer, partially because the secant formula is longer. So the secant formula in general is negative 1 over the absolute value of u times u squared minus 1. Square root u squared minus 1? Yeah. So I'm going to take the derivative of this, which is going to be 2x minus 1. That's what I'll get in top. The rest of it I will plug in. See, 2x minus 1. This is what I put in for u. For u, I'm going to simplify this, but you don't have to. And I get x to the fourth minus 2x cubed plus x squared minus 1. So again, it's plugging and chugging. If you need to pause it, pause it. Okay. Integrating your formulas, du over 1 minus u squared equals sine inverse u plus c. The integration of du over 1 plus u squared equals tangent inverse u plus c, and du over u times the radical u squared minus 1 equals secant inverse u plus c. Now you might wonder why we only have these three. The reason is because the other formulas, the only difference between the derivatives and the inverse of the other formulas is the negative sign. So we only really need to know these three. You really have to know these two, tangent and sine. They are crucial. Okay? They are crucial. They will be on the exam. So, many times integration requires some intense algebra to get the integral into the proper form. So you are going to have to do a lot of manipulation with these and use substitution. Okay. I know I'm moving quickly. Again, pause it if you need to. So, example 1, or examples, blah. X over 1 minus x to the 4th. So you need to figure out what this looks the most like. So which of our trig functions are we aiming to go for? So if you're looking at this, you should see that it most closely looks like the sine function. However, it's not. So we need to get rid of this x on the top by using u substitution. I'm going to let u equal x squared. So that means I'm factoring out an x squared down here. So du is 2x dx. And then 1/2 du equals, I meant to bring this x over with me. I don't know why I didn't. So 1/2 x du equals dx. So then when I substitute in, my x's are going to cancel. These x's, I'm going to have over 2. And u equals x squared. So how many x squareds are down here? There's 2, because we have x to the 4th. So I'm going to have 2 u's, which is x, or u squared, I'm sorry. So again, these x's right here and right here cancel, which leaves me with just this 1/2. I replace u equals x squared, but x to the 4th has 2. It's x squared times x squared, which gives me x to the 4th. So I have u times u, which is u squared. Okay, now this is something we know. If we take the antiderivative of it, we're going to get 1/2 sine inverse u plus c. And then what do you have to do when you use substitution? You always go back and plug in. So 1/2 sine inverse x squared plus c. Okay, next one. What does this one most closely replicate or look like? What does this most closely look like? Again, you should be thinking it looks most like sine inverse. Okay, remember I said sine inverse will show up a lot. However, this time we have this 4 here. We can't have a 4 there. We need it to be a 1. So how do I get a 1? Well, you're going to factor out a 4 to start. So factor out a 4. Okay, now we have a 1/4 there, which still is not good. But what can we do with the 4? If you're multiplying under the radical, what can you do? You can break it apart. What is the square root of 4? The square root of 4 is 2. So I have 1/2, because I took the square root of this 4 right here, times the integration of dx over 1 minus x squared to the 4th, 1 minus x squared over the 4th. I'm going to let x, or u equal, x over 2, and that pulls out this part. Okay, so u equals x over 2. Du is 1/2 dx, and then 2 du equals dx. So when I use u substitution, first of all, these 2's will cancel. This right here, because 2 of them, if I square this and square this, I get back to here. So u squared goes in right here. So then I can integrate. I know it's sine inverse u plus c. U was x over 2 plus c. I know I'm moving quickly. Remember to pause if you need to. Sorry. So anyways, you get the sine inverse of x over 2 plus c. Remember, you can always pause if you need to. Okay, 2 more examples. E to the x. I know e to the x's always scare you, but in this case you want to let u equal e to the x, because what is the derivative of e to the x? It's e to the x. So u equals e to the x. Du equals e to the x dx, and when you divide you get that. So you can clearly see that this and this are going to cancel, and right here you're going to be left with just u squared. So what looks like 1 plus u squared? Well, you should know it is tangent. Tangent inverse of u, plug back in, you get this. Okay, last example. This is probably going to be the most tricky because it's going to make you recall information from Algebra 2. So how do I get rid of this? This, you can't bring it, just bring it to the top, because it's a whole component. Okay, so if you bring it to the top, it's this whole component to the -1. So they're not individual pieces. So what you can do is complete the square. Complete the square. So if you do not recall how to do this, you will need to do a refresher. And again, I know I'm moving quickly, but I'm almost out of time. I only get 15 minutes on this. So when you complete the square, you get x plus 2 quantity squared plus 1. So remember, you add something on to the end. Okay, so then I have this. So now I'm going to use u substitution. What do I need to substitute in? Well, you should be able to see it's u equals x plus 2, because then I'm going to get to a tangent. It's going to look like our prior example. Du equals dx, so du over 1 minus u squared. I get tangent u, and when I replace, I get tangent inverse of x plus 2. So again, I know I move quickly. You can always pause it. I am going to post this on Schoology as well. Oh, I don't know why these are coming in different times. Here's your classwork. It is due when you get there on Monday morning at 7:15. Vanessa, remember you are on snacks, and I hope that this makes sense. If it doesn't, please email me. I will not really be available tomorrow, but I will be available, and I'll be checking my email frequently on Sunday. So hope it goes well. Let me know if you have questions, and hope to see you all at the dance tonight. See you later. Bye.